Happy weekend, everyone, and welcome to a brief lesson on factoring trinomials. So thus far in Algebra 2, we've talked about factoring basic expressions that had a GCF, where you just factor out the GCF, and then it's just a one-step problem. After you write down what's inside the parentheses, you're finished. We've also talked about factoring differences of squares, like x squared minus 9, which would become x plus 3x minus 3, and so on and so forth. And we've also done some problems that had a combination of both of those. Problems where you had to first take out a GCF, and then what remained inside the parentheses was a difference of squares that you had to factor further. Okay? That's what we've done so far. We haven't talked about factoring trinomials yet. You've done this in Algebra 1, but I wanted to give you a little refresher. We're going to start what I would consider to be the more basic trinomials, where the lead coefficient, the number in front of the x squared, is 1. And then we'll get into some more challenging ones. Okay? These guys are pretty quick, so let's go through this. Again, when you're factoring, your answer is going to be a multiplication problem. Right? You're putting this into a multiplication problem, into that form. So the way you do this, when the number is just 1 in front, first of all, you make two sets of parentheses, assuming there's no GCF. That's how you would begin. Now, when we were multiplying, if you recall, this term times this term always equaled this term. The product of the first terms is always this first term. So this must be x and x, because x times x would give us x squared. Now, for the last term, we get this by multiplying the second numbers in each binomial. So we're not sure what that could be. It could be 6 and 2, or 4 and 3, or 12 and 1, or something like that. Okay? Now, the reason I know it's going to be 4 and 3 is because of the middle term. So the middle term comes later. You first figure out, all right, what times itself, or what times what, not always times itself, but what times what gives you x squared, x and x. And now, how can we multiply to get 12? Well, there are many ways to do that, but it's going to be 4 and 3 because to get the middle term, that comes from the outside product and the inside product. So if we multiply the x times 3 and the 4 times x and combine like terms, we would get that 7x. So it's got to be 3 and 4, because if it were like 2 and 6, we'd have a 6x and a 2x. We couldn't make 7x. Okay? So long story short, the way you know how to factor if the number in front is just 1 is you got to find two numbers that multiply to 12, that multiply to the last number. Always think about that last number first. And that also add to the middle number. So the two numbers that both multiply to 12 and add to 7 are 4 and 3. Positives, all right? For this one, same idea. We have to have an x and an x, because x times x is x squared. Here and here we could have 8 and 3, we could have 12 and 2, we could have 24 and 1, 4 and 6. We don't know. There's a lot of different factors of 24. But we know it's going to be 8 and 3, because 8 times 3 is 24, and somehow with 8 and 3 we can add or subtract to get 5. All right? The other numbers wouldn't produce 5. So we need a positive 5, so this sign here must be positive, because we have to have a positive 8x. And that sign's negative, because now we have a negative 3x. So we have a positive 8x and a negative 3x, it would make positive 5x. All right? Last one. We have to multiply to negative 72. There's a ton of factors of 72, but we've got to add to negative 1. We've got to add to negative 1. So that means the factors of 72 that we have to choose must be consecutive numbers. If we've got to add to 1 or negative 1, the numbers must be back-to-back, like 8 and 7 or 10 and 11. Some numbers that are consecutive if we're going to add to just 1. So what are consecutive integers that multiply to 72? Good, 9 and 8. Okay, 9 and 8. So we have x and x again. We have 9 and 8. If we have a negative 9x and a positive 8x, we would have negative 9x and positive 8x would add to negative 1x. Okay? So the key to start is, all right, put down your x's, and then make sure these guys multiply to the last number, and then just play around and be careful to make sure you get the outsides and the insides together make your middle term, negative 1x. Right? You can always FOIL to check your work. That's what's nice about factoring. Just like the GCF stuff we did the other day, you can just multiply this out and make sure you end up with the original problem. So these are all your answers. So this is how you do this when you have a 1 in front. Really, you just find two numbers that multiply to this and that also add to the middle coefficient. So -9 and 8. +8 and -3. +4 and +3. So on and so forth. All right? Now, what if we had problems? I won't do any with GCFs today. All right? We'll do those in class. But what if we had problems that are a little more challenging with a coefficient other than 1 in front? All right? There are many ways that teachers show to do this. If I have time, I'll show you 2 different ways, or I'll just show you one today, and I'll show you others in class. All right, so let's say 2x squared plus 11x plus 5. That will be 1. Let's do another that's 3x squared. Let's have this end in a -2, and we'll have in the middle a positive 5x. And one last one, let's do 7x squared minus 13x minus 2 again. All right? Now, these are going to be about the difficulty level you should expect to see in class. The numbers don't get huge because then it just takes a long time to factor. If you have a number in front that's like a 16x squared or some other number that has a lot of factors, there's a lot of different possibilities you have to guess and check, and it takes a long time. So we don't really do that to you. We keep the front, the lead coefficient, and the last coefficient you'll usually see as prime numbers, like these, like 2, 5, 3, 7. Those are all prime numbers, right? Because there aren't many options when you're factoring with prime numbers. All right, here's the way I recommend you do this. There are other ways, but no matter what, they're not easy problems. They're a little bit challenging, all right? But I would make 2 sets of parentheses, and kind of like before with the easier problems we just did, think about it. You've got to multiply this term by this term to get 2x squared. So the only way you can really do that is with 2x and x. All right? So we force the 2x squared to happen. 2x times x. All right, these two always multiply to the first one. Now, I'm not putting in the signs until the very end. I suggest you do the same. To make 5, to multiply to 5, which is what these last numbers have to do, they have to multiply to 5, always to the last number. We could have 1 and 5 or 5 and 1. It makes a difference. If the 5 is with the 2 or if the 1 is with the 2. Different story. So look, let's try 5 and 1. Now, we forced 2x squared to happen. We forced 5 times 1 to be 5. But this is not correct, and here's why it's not. Because the outside product and the inside product, when you collect those terms, you're supposed to get 11x. But we don't here. There's no way. We have 2x and 5x. So somehow they might be able to combine to 7x or 3x or something like that if we added them up or subtracted them. But there's no way 2x and 5x can add up or subtract to 11. No way. So let's try 1 and 5. It must be. It's the only other option, right? And now you'll see why it works. 2x times 5 is 10x. 1 times x is 1x. So we have 10x and 1x. If they are both positive numbers, they can make 11x. So that's why we need both of these to be positive. Now, I always recommend putting in the signs at the end, but honestly, if all of these are positive, then these will always be positive as well. So if you notice that, if you notice you only have positive numbers, then you might as well make it plus. It'll always just be pluses. That's the answer. I showed no work because I thought through the whole thing. It was all in my head. I guessed and checked. You remember? I tried the 5 and 1. Make sure you understand why that didn't work. That did not work, right? Rewind the video if you didn't understand that. Okay, it has to be this one. And we can always FOIL to check our work. Okay, the next one. When we involve negatives, it gets a little more challenging. But again, we have to force 3x squared to happen. So that's got to be a 3x and an x. Here, ignore the fact that it's a -2. Forget it. Don't worry about the signs until later. It could be a 1 and a 2 or a 2 and a 1. We don't know yet. All right? Let's try 2 and 1. All right? Now, this one's a little tricky, I just realized, all right, for several reasons. This is one of the hardest problems you can have. When you have 5s and 6s involved, it gets a little weird. But let's play through this. It's good to have a harder problem in the video anyway. So 3x times x is 3x squared. 2 times 1 is 2. We've made that happen. Now, 3x times 1 is 3x. 2 times x is 2x. With 3x and 2x, we think, yeah, we might be able to make the 5x. But they would both have to be positive, right? for 3x and 2x to make the positive 5x, they both have to be positive. This is a little bit tricky, but that can't be the answer because these guys would then multiply to positive 2, all right? So that's not going to be it. They've got to multiply to negative 2. The signs didn't work out in that one. Usually they do work out, but in this case it didn't. That's why it's a good idea to check your work. Let's try 2 and 1. Now we have 3x. Oh no, we just tried 2 and 1. Sorry, it's Friday afternoon, I'm tired. Let's try 1 and 2. Now we have 6x and 1x. That also can make 5x somehow. See, with the 5s and 6s, again, there's several options. You got to be very careful with checking your work, all right? So we have 6x and 1x. We've got to make a positive 5x. So that must mean the 6 must be positive, and the 1 must be negative. Positive 6x, negative 1x can make positive 5x. So we have a positive 6x now and a negative 1x, right? This sign affects the outside product. This sign affects the inside product. Now we've made the positive 5x. Negative 1 times positive 2 is negative 2. It's all good. That's the answer. All right? Last one. This is going to be easier than the second one. All right? To make 7x squared, we've got a 7x and an x. To make the 2, we're going to have a 1 and a 2 or a 2 and a 1. You should try both. Let's first try the 1 and the 2. That's going to work. We've got to make negative 13x when we handle the outside product with the inside product. This is 14x, and this is 1x. That's it. 14 and 1 can somehow make 13. If the 14 is negative and the 1 is positive, we will add to negative 13. All right? So we need to have a negative 14x. That's going to be negative, and that's going to be a positive to make the 1x. This is the answer. Okay? I am on minute 12. Okay, I don't have that much time. But let me just show you one of these a different way. Okay? The first one. We'll do the easiest one this other way. All right? This is called splitting up the middle term. We know what the answer is going to be. The way you do this is just an alternate method. If you really understood guessing and checking, honestly, guys, turn me off. Have a great weekend. All right? But if you didn't really get guessing and checking, you want to try something else. Here's what I recommend you try. Multiply the outside two numbers. This is an actual method that you have to remember. All right? The guessing and checking isn't really a method. You just have to know how to guess and check. This splitting up of the middle term, you start by multiplying the outside two numbers. So 2 times 5, and you get 10. Now, you find two numbers that multiply to 10 and that add to 11. So you find two numbers that multiply to this product, 10, and that add to 11. Those numbers are positive 10 and positive 1. They multiply to 10 and add to 11. Okay? If you couldn't find the two numbers that did that, the problem wouldn't be factorable. The problem would not be factorable. If you multiplied the outside numbers and then you couldn't find two numbers that multiplied to 10 and added to the middle number, it wouldn't be factorable. Right? I don't know why I repeated myself. But anyway. So you found two numbers that did that worked. And now we split up the middle term using those two. Meaning, I write 2x squared the same way it was, but instead of 11x, instead of this term, I'm going to write 10x and 1x instead. Plus 10x plus 1x, or plus just x. And then plus the 5. The 5 carries down. So I've just rewritten this trinomial as 4 terms. And now you take out some GCFs. You take out the GCF between the first two terms. This is called factoring by grouping. Okay, by grouping. You group the first two terms together, take out a GCF, which is 2x. And you're left with 2x times x will give you 2x squared. 2x times 5 will give you 10x. Now, the next two terms, you also take out a GCF. There is no GCF between 1x and 5, so you just write a 1 outside. So plus, right, always plus or minus, but there's some operation, plus or minus, and then a 1, and you just rewrite the x plus 5. And now we've kind of forced a common factor between this big term and this big expression, I should say expression. We have a common factor of the quantity x plus 5. It's in both. So we sort of factor out the x plus 5, and we're left with what was in front, 2x and the plus 1, and we're done.